Welcome, Algebra 2 students. Today we're going to talk about imaginary numbers. And we're going to start off with the very tricky subject of doing I to different powers. This is I to the first, I to the second, I to the third, I to the 29th power, and so on, and how to do that. So we need to start off by knowing what I to the first power is. And I to the first power is defined as the square root of -1. Which is equal to just plain old I, because anything to the first power is itself. Like 47 to the first power is 47, so I to the first power is I. I to the second power is defined as -1, and this we want to know. We want to make sure we memorize this right here. And that's really the only thing you do need to memorize is I to the second power is -1. Because as we start adding powers to this, I to the third, we realize that I to the third is I squared times I to the first. Now, that is just like saying x squared times x to the first equals x to the third. This is a property of algebra 2 and equations and exponents, exponents. So for this, we need to play a little bit of substitution game here, because I to the second power we just saw right here is -1. So this is -1 times I. Now make sure, by the way, when you make your i's, you hook the i's like that. So -1 times I is -I. Therefore, I to the third power is -I. It's confusing at first. I highly recommend watching this when we're all said and done here a couple different times and working through the examples I'm going to give you. I to the fourth power is I squared times I squared, because you add these exponents. I squared times I squared is I to the fourth. Now, I squared we just saw was equal to what? -1. And -1 times -1 equals a +1. Now the cool thing that happens after you get this far through it is if I circle each of these, I to the first equals I to the second equals -1, I to the third equals I to the fourth equals 1, it starts repeating after that. So if I look at I to the fifth, well, that's just I to the fourth times I to the first. What was I to the fourth? 1 times I to the first, which was I. So 1 times I is I. And we see the cycle of 4 starts repeating. So if we had to take a guess here, I to the sixth would be -1, because it goes 1, 2, 3, 4, 1, 2, 3, 4, and so on. It repeats every 4. If we weren't 100% sure of that, we would do I to the sixth is I to the fourth times I to the second. Okay, now look back at what we've done so far. What is I to the fourth? 1. What is I to the second? -1. So I to the sixth equals 1 times -1, which is -1. And we can see what's starting to happen here. It goes I, -1, -I, 1. Here it is again. I, -1. And the next one, I to the seventh, would be -I. I to the fourth would be 1. So this is cool. We only have 4 different ones, because they all start repeating in chunks of 4 after that. But this is all good. And like if I said, okay, what is I to the 8th? You could probably figure that out, that I to the 8th is the same as I to the 4th, because that's this pattern that it's going on. 5, 6, 7, 8 would be like 4th, so that should be 1. If we had to check it, I to the 8th is I to the 4th times I to the 4th. And I to the 4th, what was that equal to again? 1. Good. 1 times 1 is 1. So I to the 8th and I to the 4th are the same thing. Now, here, on a scale of 1 to 10 on how confusing that is, it's a 9. Okay, it's very confusing at first. If you're sitting here looking at this thinking, what in the world? It's normal. You have to keep looking at this. Because if I give you one like I to the 29th, well, nobody wants to sit here and keep counting up like that. Because I suppose you could, but if I gave you I to the 2009, that would be quite annoying to do. So you need a technique, and here's the technique I use to do this. I take the number 4, because I love this right here. I to the 4th equals 1. That is the best thing ever. Because if I take 29 and divide it by 4, I get 7. And it goes in there 28 times. And if you do this on a calculator, it's going to go in there 7 point so many times. So I know it goes in there 7 times. So I know that 7 times 4 is 28. So I can make this I to the 28th times I to the 1st. And remember, with all these examples I've been doing, like if we back up and look at this, I to the 3rd is 2 times 1. I to the 4th is 2 times 2. I to the 5th is 4 and 1. Again, you're adding these exponents. So it's 2 plus 1 is 3. 2 plus 2 is 4. 4 plus 1 is 5. Here, 28 plus 1 is 29. Now, why did I pick 28? Because 4 goes into it. 4 goes into it. Meaning, I to the 28th falls on that cycle of 4, just like I to the 8th does. So I to the 28th, I know, equals 1. And 1 times I to the 1st is 1 times I. So that equals I. Okay, now what I want you to do, I'm going to give you one. I to the 57th. I want you to, when you're watching this, pause the video, try to do it right now. Okay, now we're going to go ahead and do this. So if I had to divide, a technique I do is I take 57, divide it by 4, and it comes up 14.25. So I know that 4 goes into 57 14 point so many times. So I know it goes in there 14 times. So if I take the number 14 times 4, I'm going to get 56. So that I know that I to the 57 is I to the 56 times I to the 1st. Because 56 plus 1 is 57. Now the reason I do that again is 4 goes into 56. Okay, 4 goes into 56, and I to the 4th is equal to 1. So anytime that happens, this first number is 1 times I. And I to the 1st is just I, so this final answer is also I, and that was just a coincidence that both of those were the same like that. Okay. Well, that's imaginary numbers, and I do recommend you watch this again, and you can actually use Google if you type in quote I to the 29th and hit enter. It will actually tell you what the answer is, so you can make your own examples up on the side and check it. Just type in I to the 13th, like if you literally type that out, and it will come up with the calculator and tell you the answer. It's pretty wild. I will talk to you tomorrow.